Hello everyone, Dr. Fazal is here, and today in this session we are going to discuss in detail that what is cloud computing, what is the motivation behind the cloud computing, why the people, why the organizations or the individual migrate towards the cloud, and what are the key technologies which are used to process a massive number of data or to store a massive number of data. So we will look on all in that, and we will complete this in 1 hour. So before that, we must understand that what is actually a cloud computing. We use the cloud computing every day in our daily life. For example, if you are using any Android phone, then definitely there will be any drive where your photos or your videos will be automatically copied to it. And if you are using the OneDrive, for example, Microsoft OneDrive, then your photos or videos are copied to the OneDrive. And similarly, if you are using similar type of application, you are using a Gmail, you are using Yahoo Mail, etc., then you receive the mails, you send the mails when you go to the office. Or if you are using the WhatsApp, then the data which you receive on the WhatsApp, the video or the text which you receive on the WhatsApp, definitely this data is stored on the WhatsApp servers. Or if you are using any social media, then the content, the feeds which are shown on the wall, which are shown on the feeds, then these feeds, this data, the videos or the photos are actually stored on the social media cloud servers. So every one of us are connected to the cloud on one way or other. But maybe for some people the cloud computing terminology will be new. So what is cloud computing? How we define the cloud computing? Cloud computing is actually utility services. We can say that cloud computing is a utility services. So how is it a utility services? It is just like a utility service as we use the electricity, we use the gas, or we use the water at home. We don't know the complication behind the electricity, that how it is generated, how it is supplied to it our home. We are unaware the complications, we are unaware behind the technologies behind it, the resources which are working for that. We just use it and we pay it at the end according to our usage. Similarly, related to the gas or the water, we don't know the exact complication behind it, that where this gas is processed, where this is produced, how this is supplied to the people, to the home or to the organizations. We just use it at our home and pay it according to our utilizations. So cloud is exactly like that, that it provides the desktop resources to the people online on the internet. This may be in the form of memory, this may be in the form of storage, this may be in the form of computing, this may be in the form of networking. And if we use any type of application, then this may be in the form of application. Or if we are using any type of platform for development, for deployment, etc., then this may be in the form of platform, etc. So the next question is that why cloud computing? Why should we go towards the cloud computing? There are number of reasons that people and the organizations go towards cloud. They migrate toward the clouds. There are a number of benefits. Let's look at that one by one. You can see these on the screen. That the first one is 24/7 availability and support. Cloud computing services are available every time. Its support is available on every time. It is because all the things are the cloud, and the cloud use their own algorithms for corrections, for facilitation. So it is available, it corrects itself. So all the things go on 24/7. There is no need to work any particular hours, as we can see in the market or we can see in the physical businesses. The next thing is the lower cost. Lower cost means that if, for example, if you want to travel from one city to another city with your family, then you hire a minibus. You don't go to buy this. You just hire this and pay the hiring prices. Exactly like that in the cloud, if you are using any type of infrastructure or any type of software, instead of buying that, you just hire that, which cost or very lower prices. The next thing is location independent, because all the things are on the cloud, the business is running on the cloud, so it is location independent. Any people around the world, the people who have the facilities, they can connect to this business, they can connect to the cloud providers. Pay as you go, you just pay according to your utilization. And similarly, there is no worries about backup and recovery, because it is automatically works. And as we also know that the technology, for example, Hadoop, it replicate our data at three different places. So if the data is deleted and accidentally deleted, or it is removed from one place, it can be recovered from any third place. It increase the utilization means that in term of, for example, if there is a single system means that only one person is connected to it. But if the system is high power computer, then this utilization will not be utilized, because only one person is connected to it. But if we connect this computer to the network and the people around the world are connected to it, then definitely its utilization will be increased. And the resources which usually go underutilized during its home, during utilization by one person, this will be increased up to 90 or 100% when it is connected to the internet. It is self-services. It utilizes different type of AI. It use different type of AI models, algorithms for diagnostic, for self-corrections. So it is a self-services and automatically improves its services. A very best thing with the cloud is its scalability. For example, if you are using any one single system, the issue with that is the scalability, because in the single system we usually utilize the vertical scaling, and the vertical scaling is very costly, it is very difficult to do. But in the cloud computing services, we use the horizontal scaling, and the horizontal scaling is very easy to do, and it is not as high or complicated as we do the vertical scaling. So all these benefits, all these technologies, all these the characteristics which are related to the cloud computing shows that cloud computing is very important, and it is the need of the day. And this is the reason that the people and the individual and the organizations migrate their services towards the cloud. So the next thing is that why do we need the cloud computing actually, or how the big data is generated. We use actually the cloud is used to process the data which is generated around the world. So it is expected that there are about 20 or 25 billion devices which are connected to the internet. And it is expected that up to 2030, these devices will be increased up to 50 billion. And somewhere, for example, the statistics shows that these devices will increase up to 75 billion devices. The total populations of our world is 7.5 billion people, and the devices connectivity which is expected is 50 or 75 billion devices. So this will produce a very big data, a massive big data, and definitely this data will be directed towards the cloud. And how this data will be executed on the cloud, this is challenge, this is definitely a problem for the technologies, for the tech companies. So this is the reason that we go towards the cloud computing, to process this big or massive data. Because the big data is scored towards the cloud computing, so definitely this is the question that what is actually a big data. I have answered this question in detail in one video, and you can also watch this, that what is actually a big data and what type of technologies are used to process or store or execute this big data. in the normal way, if we are not a computer scientist, or we are not working in a big data, or we are not connected towards the to the cloud computing, then big data, as the word suggests, that it is a massive amount of data, but only the volume is not able to define the big data. Actually, we need a minimum three V's, which were actually used in 2001, and these three V's are actually used to define this big data. Nowadays, five V's, and sometimes 17 and 20 V's are used for the characteristics and the definitions of the big data. But these three V's are very important. Are I would say that these V's are enough to define the big data, that what is actually a big data. So the first one is the volume. As the word the big data suggests, that this data is very big, very massive in the volume. The second thing is variety. Variety means that this data is not in the form of a single variety, but it is in the form of a different variety. This may be structured data, this may be unstructured data, this may be semi-structured data, or we can say that this may be any type of text, numbers, this may be in the form of audios, videos, or photos, etc. The third one is the velocity. Velocity actually refers that this data is generated with a continuous speed. So if there is any data, it is in a different variety, it is massive in the volume, but this data is constant, it is not further generated. So we can't say that this is a big data. So if we see all these three V's, the volume, variety, and velocity, and apply these three V's and on the today's social media, then we can see that all these social media platforms are actually dealing the big data. This data is very big in volume, very massive in volume, because the people around the world are connected and they generate a data in very high speed. So it also cover the velocity. The third one is the variety, that the data uploaded on the cloud, uploaded on the social media, they are not in a structured form. This data is in unstructured. People write posts in the form of text, numbers, they upload the audios, they upload the videos, they upload the photos, etc. So this data is also in the unstructured form. So we can say that the data which is available on the cloud, the social media cloud, this is the very good or best example to define the big data. So what are the motivation behind the cloud computing? Why we go towards the cloud computing? Or what are the expectation, assumption, or what is the future of the big data, the cloud computing? You can see in this figure, in the statistics, if for example, if you see the data sphere, that in 2027, 20 zettabyte data was generated, and similarly if you see the same figure in 2025, which is expected that about 175 zettabyte data will be generated. And similarly, if you see the devices in billion, I got this statistics from statistic.com. I'm not exactly sure that either this expectation is true or not, but these expectations or these assumptions are taken from a well-known organizations or government agencies. The second one is the devices in billion, and if you see this in the 2017, then there were about 20 billion devices connected to the internet. But if you see the expectation, then up to 2025 or up to 2030, there is the expectation is that 75 billion devices will be generated. In the earlier slide, there was mentioned that 15 billion devices are connected to the internet. So this is not an exact figure, this is the expectation, this is the assumption which different organization, well-known organizations or the government organization expect or they calculate. And similarly, if you see the investment, then in 2017, 35 uh, billion were invested in 2027, 2017. And if you see the same expectation or assumption up to 2025, then you can see that about 90 billion will be invested in the cloud. So all this shows that the cloud is very rapidly growing. People are investing, and that the number of devices connecting to the internet is also increasing very rapidly. The data generated by these devices are also increasing very rapidly. Definitely this will need the technology, this will need the expert to execute this technology. So all this shows the growth of the cloud computing. So let's talk about, once again we come back towards the cloud, that what is actually cloud computing, what type of services it provides, and how it is actually deployed. In the last slide, we see that what is actually cloud computing. We define that the cloud computing is actually a utility computing which provide the desktop services online on the internet. This may be in the form of services. For example, if you use the Gmail, if you use any type of monitoring services, it may be in the form of platform. For example, if you use any type of platform, for example Google Cloud, to develop any type of applications, or it may be in the form of infrastructure. If you use for example OneDrive or Google Drive to store or to store to store your data. So the services provided by the cloud computing are actually categorized into three different categories. The first one is the IaaS. IaaS means that infrastructure as a service. Infrastructure as a service means that when the cloud resources are provided, the cloud infrastructure are provided on the internet. When you use the memory, when we use the computing power of this of the servers, when we use the bandwidth, the power of any type of network. Nowadays we use the Android phones, or we use the laptop, which computing power is not very high compared to the resources which are needed, compared to the resources which are needed. So what we do, that instead of using the Android CPUs or in the Android memory, we use the cloud computing power, the cloud memory power, to process or handle our data. For example, if you are working on the Canva and you are processing, editing a very massive video on the Canva, then the resources which you are using at that time, the computing power, the memory, all of these resources are utilized are owned by the Canva servers. The second one is the PaaS. PaaS mean platform as a service, where you provide the where the cloud provider provides a platform to develop an applications, to deploy an applications. For example, you use the Google Collab. Google Collab provides you different type of facilities to develop any applications, or you use the GitHub. The third one, I don't exactly know its name, the GitHub IO, etc., which give you a complete studio where you can use any type of languages and you can develop or deploy any type of application. So why do we use these applications, or why do we go towards these applications actually? That sometime our platforms, our computers don't have the resources which are required to develop any type of particular applications. For example, if you are going to develop any type of applications which depends on, or which need more than one processor, this is a parallel processing application which need, for example, 36 or 100 CPUs, then your computer have only 4 or 8 cores, 8 CPUs. So your system would not be able to process this data or to develop or test these applications. Definitely you will need a system which have more than 100 or 200 CPUs. For that, we go towards such like infrastructure as a services, where we develop applications, where we test and deploy our application. The third one is the SaaS, which means that software as a service, where instead of developing, deploying your own application, you just had these applications and you use that for your organization. For example, if you have any type of organization, it may be in the form of school, any educational institution, or the university. So instead of developing your own examination system or the HR system, you just hire any application and you deploy that in your organization, and you use start using that. So this is a SaaS. You use the Gmail, etc. Instead of using to develop your own Gmail services or email services, you go towards the cloud, you go towards the Gmail or the Yahoo, you create your own account and you started using the Gmail services, etc. So what is this? This is a called a software as a service, where you just hire any services of software instead of buying it. So what are the three basic services of the cloud computing are? The first one is the IaaS, the second one is the PaaS, and the third one is the SaaS services. And definitely, what are the deployment services or the deployment model of cloud computing, that how the cloud computing services are deployed to the people, deployed to the organizations. This is divided into three basic models: the private model, the public model, and the hybrid model. Private model means that the resources of the cloud is only available to the organization employees only. For example, if we talk about the bank, then the applications, the infrastructure, or the platform, this is available only to the bank employees. So the people related to the bank, working in the bank, only these people can use their cloud resources. No third person is allowed to use these resources, or there is no service level agreement between the people, the public, and the bank services. The second one is the public cloud computing. Public cloud computing means that all these services are available for the public. If they want any type of services, this may be in the form of storage, computing, or processing, etc., or they can use any software, or they can use any development infrastructure platform, then they go towards any public cloud platform. They sign the service level agreement and they started using these applications instead of buying that. So the examples are the Google. We go to the towards the Google's Drive or OneDrive. We sign their agreement, we pay their fees, and after that we started using their OneDrive or Google Drive, etc. Similarly, if we use their applications, we do the same. We sign their service level agreement, we pay their charges, and we starting using the same application. The third one is the hybrid cloud computing. As we discussed, that the private is private. It is available only to the organization employees or the organization people. And as the public cloud, it is available for the public. Public pay it, public pay for it and use it for their own requirements. So the hybrid cloud computing means that this is basically private, but if the resources are underutilized, then these resources are provided to the public to get some revenue and utilize all these resources. For example, if there is a university, they have a very high power computing, or they have a very high power computing server. So sometimes they outsource these underutilized resources to any third company as a edge, and the third company use their resources as a edge. So what is the benefit? That the university resources are utilized properly, and similarly the company or the people which are hiring these resources, they also get some benefit from these resources. They get the resources in the cheaper rates. So when a private organization provide or outsource some of their resources to the public, to any third party, that this is called a hybrid computing. So what are the three deployment models of the cloud computing are? The first one is the private computing, the second one is the public cloud computing, and the third one is the hybrid cloud computing. So let's go towards the key technologies which are related to the cloud, because as earlier we discussed that cloud computing means that we actually process or store the data on the cloud server, uh, which is which may be located anywhere around the world. This may have a very long distance from the clients, and as it is located on the cloud, and this also means that the people or the devices around the world would be connected to it. So the cloud server will definitely get a very massive amount of data. This is not any ordinary data, a very limited set of data to process or store it. This is unstructured, a very massive, and a data which is generated with a very high velocity. As we saw the example of the social media applications, that the people around the world are connected, they upload their videos or audios every second, and this data is in the form of unstructured data. So definitely these resources, these servers, these providers have different type of challenges to process, store, or replicate this data. So definitely we will need some sort of technologies to process or store this data. So some of the technologies you can see on the application, that for example, the Hadoop is very popularly used to process and store the data on the cloud. But before discussing the Hadoop, we should look at the parallel processing and distributed processing first. Parallel processing means that if there is any system and it is highly utilized, and there is any single processor, then the processor is very high, but it is a single processor. So the data must be in a queue to be processed, and this data must be processed in a serial wise. But if we put more than one processor there, for example 10 or 20 or 50, then instead of waiting in a single queue, all of this data will be distributed on 50 processors, and this data will be processed instantly. In a very limited in a very short time. For example, you have a chef in your kitchen, and he is very expert, and he used to prepare the dishes or the meal for the family. But if there are any visitors, there are 50 people who are visiting you, then at that time you have to prepare some dishes for these visitors or for these guests. So in same situation, if you put the same one chef into working, he would not be able to prepare the meal for 50 people in the exact time which he usually takes to prepare the meal for 5 or 6 people. But if you use to hire 4 or 5 chefs for that day, then the workload will be divided into 5 or 6 chefs. So in the same situation, if the first chef was taking 5 or 6 hours to prepare these foods, the 5 or 6 chefs would take 1 hour to prepare all these meals. So exactly in that application, exactly just like this application, instead of processing the data on a single processor, we process this data on more than one processor to process this massive data in a very short time. Distributed processing means that when this data is distributed, geographically distributed around the world, or on any server to process this data, this is a similar this is we can say that this is similar of parallel processing. Parallel processing happen usually on a single server on a single computer, but distributed processing means that we are processing data distributedly. For example, we are processing the regional level data. We have the servers there, and data is processed on the regional level. and for example regional 1, regional 2, and regional 3, and after that the results are combined in a single place. So we were talking about the Hadoop. Hadoop is a technology which are usually used for parallel and distributed computing. This project was started in 2006, and after that, this is actively used to process and store the large data set. Apache Spark, which was started in 2009, and latterly this was owned by Apache in 2014. This is actively used to process and analyze, particularly to analyze the big data, and it is about 200 times faster than Hadoop because it used the in-memory processing techniques to process this data. The third one is the NoSQL databases. We actually usually listen about the SQL databases. We work on the SQL databases, but the SQL databases means that it store or process only relational tables, relational data. But what to do if there is unstructured data? The data is not in the form of any particular relation. As we talked to define the big data, we define that the data is in a different variety, in a different form. This may be structured, this may be unstructured, or this may be semi-structured. Then definitely we will use NoSQL databases to process or store our unstructured data. MongoDB is very important and it is actively used to store or process such like data. We also use the data warehousing. Data warehousing is a location or the technology which actually used to store this big data. So once again, we are on the parallel processing. We discussed that in detail, that what is the parallel processing. So there is no need to discuss it again. Parallel processing means to process the data on more than one processor. Distributed computing means that to divide the task around the world into different location-wise regional server and to process this data there on these services. Hadoop, as we discussed, this is the open source framework to process big data. It is also actively used at that time too. It uses a distributed processing across cluster to process and store this data. It is highly scalable and we can say a cost effective solution, and its core components are Hadoop file system, Yarn, and MapReduce. Hadoop actually have different type of data nodes and name nodes. Name node is just like a server. It get the request the from the organizations around the world. Then this data is further sent towards data nodes, and data nodes process these requests, process this data. Apache Spark, this is actively used nowadays. It is in-memory processing. It is about 200 times faster than the Hadoop, but it also work with the Hadoop. It uses the Hadoop file system. It uses the yarn management to process and store this data. Apache Spark is particularly used for AI models to analyze the big data set for number of purposes. NoSQL database, it stores the unstructured data. It is very flexible. It is also very scalable, which we can't see in a relational database, because relational database work on a particularly schema. We actually define a schema, then we strictly follow this schema. This schema can't be changed later on. For example, if you have defined one table and this table have five different attributes, five different columns, and then you define every column with particular integrity, that the integer data will be stored there, the text or integers will be stored. So after that you will not be able to insert any other type of data. But in the NoSQL databases, we can say that this is very flexible. There is no such type of rigid or strict rules with the NoSQL databases. Similarly, it is also very scalable because it works with the cloud. It handles the big data, so it is very scalable. It is its performance compared to the relational database. Its performance is very high, and it works in the distributed architecture. So these were the basic technologies. We must know about the Hadoop, the Apache Spark. We must know about the NoSQL databases. We must know about that what is parallel processing and what is distributed processing, and these are the basic things which we must know, that how the data in the cloud is processed, and how the data on the cloud is stored, and or what type of technologies are used to handle this data. In the next slide, you can see the applications of the cloud computing. Cloud computing is everywhere. We use that for every application nowadays. There is there is no domain where cloud computing is not applicable, or there is no utilization of cloud in that domain. As we can see in today world, that computing power is everywhere. The computer is utilized by every organization, every domain for their tasks. Exactly, nowadays the cloud is used, or it will be used for every type of applications or every type of department. So in this figure, you can see that it is used in healthcare, and in the healthcare we can see this the cloud application in the hospitals. We use then it in a telehealth, which is becoming very important, and we also use it for research, for diagnostic purposes, etc. We use the cloud computing in the supply chain management. We use that for transport, and we can see you can see the electric vehicles are the autonomous vehicles, which are very important, or we can see in the drones. Nowadays the delivery or the logistics or the supplies done by the drones. So the cloud, the technologies are used to handle the drones or these or vehicles, etc. Marketing and advertisement, we see every day, we observe every day that the YouTube, the video platforms, or the social media recommend certain types of advertisement, the video, etc. So all these actually depend on the cloud. They depend on the big data applications which are used to uh, which are used to uh, it is they actually use the big data and cloud computing technologies to for these recommendation system. Smart cities is very important. All their data, smart cities data, are stored and processed on the cloud. We use that for urban planning. We use for IoT infrastructure. So all this data generated by the smart technologies are stored and processed on the cloud. And media and entertainment is also very important, because media generate or the entertainment generate a very big or massive data. So this data definitely need certain sort of technologies to stream this data. For example, the Kafka platform, the Apache Kafka platform, which is very important for the streaming, so all these data which is generated by the media entertainment, they need any sort of big data technologies at the cloud to process and distribute this data. Cybersecurity, in a cybersecurity, we need the big data and the cloud computing to get certain types of analysis. In the climate and earth science, as we can see, the GIS, the Geographic Information System, they produce a very high definition map, videos, and photos, etc. So all this need big data technologies. They need a cloud to store and process this data or further analyze this data. Similarly, in the industry, as we can say, that Industry 4.0 has revolutionized the way of working of the industry. So we need that in the cloud and the big data technologies in the industry too. Education is particularly really very important, because particularly after the COVID-19, we shifted toward the e-learning platforms. We use different type of e-learning. We usually do the online meetings, online classes. We actually work on we work on the virtual platform. So it is also very important in the educations. This figure don't show that only these are the platforms, or only these are the domains where the cloud or big data is used. Cloud computing is everywhere. We use it in every domain, in the every field of life. So as we discussed in very detail, that cloud computing is very important. It is a part of our life. We use this in daily life activities, and our life depends on it. But definitely, if there are too many benefits of the cloud, there are too our lives are getting easy with the cloud and the big data, then definitely there must be some sort of challenges, there must be some sort of issues with the clouds. So what are these potential concerns with the cloud computing? The first one is the network congestion. Network congestion means that the network is carrying more data, more workload than the available capacity. So if we are having 50 or 75 billion devices, and all of these devices are generating that data, and we are migrating that data towards the cloud, definitely our network will be congested. This network will not be available for the real-time application, particularly in the evening time or in the peak hours. We see that the network is not available even to stream or even to talk to our friends on the Zoom or the Skype, etc. This exactly means, because at that time every person is connected to the internet, they work on the internet, they talk to their friends, so a massive amount of data is generated, and this congests the network. Particularly this is issues for the real-time application, the healthcare application, the UAVs applications, or the drones, if they depend on the network. The second one is the special hardware and software. As we talked earlier, that if the data is massive, if there is a very massive workload, we will not be able to process this data on a single processor or any single server, etc. Definitely we will need some type of parallel and distributed technologies to process this data on a number of processors and number of regional servers. So we need a special hardware, we need special software to process this data. We can't go with big data or with the cloud with ordinary applications. And if we use special hardware or special software, definitely we will need a technology expert. If we are using Hadoop, that means we will must have any expert of the Hadoop who would be able to execute it or diagnose it or connect it. And similarly, if we are using a Spark, or if we are using any NoSQL databases, for example, the MongoDB, then we need to have the expertise of these experts, and definitely this will cost very high. Privacy and security is the main concerns with the cloud computing, because devices yours and the data is the company where this data is particularly stored. So if our data is stored on any cloud with a third party, uh, it means that our data is not private. There may be some sort of issues with the privacy, there may be some sort of issues with the security, etc. In 2016, the schools were asked in Pakistan to install the cameras, CCTV cameras, in every organization, and all these cameras were connected to the cloud, and there was a single simple password and login ID to access the DVR, the videos of any educational institution. So at that time I had a strong concern on that, because these uh, videos or this CCTV data is not private. Anyone can access this data, particularly the terrorist for which this system was installed. They can also easily use these applications. They can also get easily access to these videos, and they can use this for any type of disaster. Businesses are particularly very big issues with the big data and the cloud computing, as we usually see nowadays with the AI platform, for example, the ChatGPT or the Gemini, that they have some type of business with the culture, with the languages, etc., because they are actually trained for a single culture. They are trained for single geography, and this will take a time to remove this biasness. Misuse of data, if our data is on the cloud, and if any third person get connected to it, then there may be some issues of the misuse of this data, and definitely this data can be misused by any other people. The next issues with the cloud or the big data is the different cyber rules. If you are sitting in a one country and you are writing something on the social media, or you are posting something on the social media, this will not be a crime in that country. But in the next moment, if you fly to any other country, that this may be a crime in the second country. So there are no unique rules to control the cyber or the internet. So definitely this is a big issues with the people who are connected to the internet or who are connected to the cloud. The next one is the doubted accuracy. Doubted accuracy means that the data available on the internet, we can't exactly say that this data is correct or not. So there is a doubted accuracy also with the cloud computing. So all of this was related to the cloud, that what is cloud computing and why do we need the cloud computing for our daily life, or why do we migrate towards the cloud. So let's take a one short recap to cover that what we actually discussed in this video. Cloud computing, as we discussed, that it is a utility computing. The cloud providers provide the computing services just like a utility. We use that at our home, and we are unaware about its complexity, its geographical locations, and how it works. We just pay according to our utilization, as we usually do with the electricity or the gas. The second thing is that why do we use the cloud computing? It is 24/7 available everywhere. Its cost is very lower. Instead of buying the infrastructure, it is location independent because it is on the internet. We pay according to our utilization, as we usually do with the electricity or the gas. We are not worried about the backup and recovery because it automatically works, and it increases the utilization of the underlying resources because the people or the devices around the world are connected. It self services because different type of AI algorithm works. Scalability is the main issues, but in the cloud there is no scalability issue because it actually work in the uh, horizontal scaling, and in the horizontal scaling there is no scalability issues. So why cloud computing, and how much data is generated are sent towards the cloud computing? But the first thing is the devices, that about 15 billion, or we can say that 50 or 75 billion devices are expected to connect it to the internet up to 2030, and definitely they will generate a very big data. Big data means that it is very massive in volume, and it is generated with a high speed, as we can see in the social media, that every second people upload their videos or photos, etc., and definitely it store a variety of data. This may be structured, unstructured, or semi-structured data. What are the motivation behind the cloud are, as we can say that the data sphere, the data generated by these devices are very high in numbers, and its growth is very high. We can see the devices which are connected from 2017 to 2025 or 2030, which is expected up to 50 or 75 billion devices. And similarly, the investment, you can see that it increases from 35 to 90 from 2017 to 2025. So all this show or all this motivates the individuals or organizations towards the cloud. And the services of the cloud computing are divided into three categories, which are SaaS, means software as a service, PaaS, platform as a service, and infrastructure as a service. And similarly, deployment models are divided into private cloud computing, public cloud computing, and hybrid cloud computing. As discussed, that private cloud computing is available only to the organization. Public cloud computing is available to every persons. They just go there, hire, pay the subscription charges, and they start utilizing these applications or the services. Hybrid cloud computing, where the private and hybrid cloud computing works together. The key technologies behind the big data is the Hadoop, Apache Spark, NoSQL databases, just like a MongoDB, data warehousing, parallel processing, and distributed processing, which are actually the core. And similarly, the issues are the applications of the cloud computing, that it is actively used in the healthcare, it is used in the supply chain, it is used in a marketing and advertisement, smart cities particularly. It is used in media and entertainment. We can see it in a Netflix or a YouTube, etc. Cybersecurity also use the cloud or the big data for analysis purposes. And the climate and earth science, as the GIS or the satellite produce or generate a very high definition photos, videos or maps, etc. Definitely we use the cloud technology process or store or analyze this data. And definitely industry 4.0 definitely completely depend on the cloud. And education, after COVID-19, we have observed that the education institutions are shifting towards the cloud. So what are the potential concerns? There is a network congestion, there is a special hardware required or the special software required to execute or work on the computing, work on cloud computing. It depends on the technology experts. There is a privacy and security issues. There is a biasness. There is chances of misuse of the data. There are different type of cyber laws, and definitely there is a doubted accuracies with the cloud data. So this was all about the cloud computing, and thank you so much for watching.